All right, exercise 5D. This is just revision of last year's logarithmic rules, which for most students, that is the first time you've seen it. For students who were in the enhanced class would have seen logs in year 10. So then it might be a bit more familiar. But regardless, this is probably one of the ones that students generally find hard to understand to move between exponentials and logs. So those who are sort of struggling towards end of year with exam 1, often it means their exponentials and logs aren't as good. So if you're in that boat, this is probably one of the first areas to start working with because they do it in exam 1 quite often. Let's do a bit of revision. Here we go. So log properties, we know that you can't do the log of a negative number. So that's what this means here. So it does not exist if x is less than or equal to 0, saying that you cannot substitute a negative number in there. So I can't do something like log 10 of negative 1. Okay, that doesn't exist. And if you knew the graph for a logarithmic graph, it also makes a lot of sense as well. We do not have any y values in the negative region. Okay. So that's an exponential graph. So there we go. So you don't have any x values in the negative region. That's why x cannot be less than or equal to 0. Okay. All right, so if you know the graph really well and then you know the equation well, then those properties will come about. So we know we can't do log of negative values. We know there is an asymptote at x equals 0, which I kind of drew it to you just then, that there's a vertical asymptote at x equals to 0, and it will always have an x-axis intercept in some way. Okay. All right, now let's go through log laws. Should be very similar to exponentials. Let's remember log law number 1. If you have log base a of x plus log base a of y, you can simplify that to become what? Let's go with Aryan. Do you remember this one? What does this become? Log base a of? Very good. X times y. Becomes xy. And then the next one, log law number 2. If you have log a of x, take away log a of y. What does that simplify to? Let's go with Ewan. X divided by y. Beautiful. So very similar to exponentials, just the reverse. And then log rule number 3, which is probably the most popular in the exam. That's how they normally get students. Students tend to remember log law number 1. Sometimes they screw up law number 2. But log law number 3 is what students tend to miss out on if you're struggling algebraically. So exam 1, that's how I generally know, based on just looking at the third law. So what is the third law? Let's go with and. Do you remember what the rule is for log a of x to the power of n? It is the same as, beautiful, n times log base a of x, meaning you can just drop the power to the front. That's one of the key rules. And I'll show you in the next example why rule number 3 is popular in the exam. Then that extends to log law number 4, which comes from number 3. This is the same thing as writing log base a of x to the power of negative 1. So in next laws, they can write 1 on x the same as x to the power of negative 1. And if I use log rule number 3, bring down the negative 1 as a power, then you get negative 1 times log a of x. So sometimes they just write it as negative log a of x. So that's rule number 4. Number 5, I mean, they split up to like 5 and then 6, but to me, if you know your exponentials and you understand it, then this one makes a lot of sense as well. But for most students, I find that they memorize this. That's why they get it wrong in the exam. So log a of 1, what does that equal to? Let's go with Sarush. 0, very good. And this, how I interpret it, it's how you understand what log means. Log is finding the power. Yeah, exponential uses the power. Log finds the power. So what this line is saying is a to the power of what? So what power will give you 1? So if you understand that meaning, when you look at it, you're just simply saying what power for a with a base a will give you 1? Well, 0. A to the power of 0 has to give you 1. Okay, this is the interpretation of how you read it. So if you read this one now, this is saying what power with a base a to the power of what will give you a? It would have to be 1. Very good. Okay, so you don't have to memorize that per se. It's just understanding what does log mean. But number 3, I would say this. Got to be careful. I'll show you why. I'll just jump to the example on the bottom down here. Example 1. You see, this is a typical, if I chucked in exam 1, you could probably get something like that for the first SAC this term. You see, what most students do is they see the plus, they see a log base 10. So what you naturally would want to do is you want to combine those two. Rule number 1, because that's what most students are really good at. So rule number 1 says, oh yeah, I can write log base 10 and it'll be 16 times 5 squared. Nothing wrong. Feels good. And then just put the half at the front. True? Problem with that is you just made up your own rule. The rule never stated that you can have a coefficient b and just do that. It never said that. It's just saying if you just have log base a of x plus log base a of y, never said there was a half multiplied to the first one. Never said that. So you can't just combine that. So one of the hidden ones they do in the exam is they test that. Anyone who gets that wrong, usually it's because they did this. So the proper way was you couldn't have done rule number 1. Rule number 1 couldn't have existed. Rule 1 doesn't work because of that half. We need a log at the front. No coefficients, no powers. Oh, not powers, but no multiplying. No factors. So the only way to do that was you had to convert this one using rule number 3. So rule number 3, we said, well, the value at the front, you can make it the power. So this now becomes log base 10 of 16 to the power of half plus log base 10 of 5 squared. This is the correct step. Okay, and that's where they hide that rule number 3. Rule number 3 comes in right there. Okay, rule number 3, and then everything else is pretty much Bob's your uncle. So we go 16 to the power of half is the same thing as what? Can I please have, let's go with Ishan. What's 16 to the power of half the same as? Very good, it's square root. So for those who don't remember, half to the power of half is square root. So square root of 16 is 4. So you can say it's log 10 of 4 plus log 10 of 5 squared, which is 25. And then putting it together, this is when you can use rule number 1. So it has log base 10, it has log base 10, fits rule number 1. So now we can say it's equivalent to log base 10 of 4 times 25, and that gives you log base 10 of 100. 4 times 25 is 100. You got to evaluate that though. If you leave that in the exam, they'll take off a mark. So they kind of assume that you don't know how to read that notation or what that actually means. But if you read that, based on what I've been teaching you so far, that means you're looking for the power. 10 to the power of what will give you 100? What's the answer? Frisch? 2. Very good. Okay, so you need to write the answer if it's something like that. If you leave it, if it's something valuable, like you can evaluate it, and you don't, they will take a mark off. Okay? So that won't be simplified. All right, let's roll back. So we've got through the 5 laws that you were meant to practice from last year and sort of understand. Then there was another rule that either your teacher would have taught you the reasoning to it, or you just memorized it. It is called the change of base formula. Now, the reason why this is not well learnt in the later years, when I say later years means during my time, this was a very popular, the only technique that you had to definitely learn for logs. You guys now don't, because your CAS calculators do it all for you. That's why you never had to learn it. But they do check it in the exam. There was one, it's towards the end of your notes there. It's a really cool multiple choice question. It was the last one of 2010 or 2020. I can't remember which one. But most students got this one wrong. Okay, so this is called a change of base formula. And how it works, or how, like, for example, if you have log base of, 3 of 10. The rule says this is equivalent to you doing log of any base that you want. So I could do log base e of 10 divided by log base e of 3. That's what the rule's saying. Okay, so the key part is this, the b part. And A could be anything, B could be anything, yeah? Why is this important back then for me, and maybe not for you now, is because back then our calculators, our CAS calculators, could not do what you can do now. We couldn't type log base 3 of 10. It just didn't work. Okay, our calculators kind of work like your scientific. You don't have a log base 3 of 10. On your calculators, your scientific ones, they only have ln, which is log base e, and log, which is assumes base 10. That's the only two logs that most calculators have. Your CAS calculators, on the other hand, can do any bases. So that's why you feel you don't have the need to learn this skill. For me at the time, if I had a question that came up as log 3 of 10, I had to. There was no other way for me to do it. I had to convert it to this and then use my calculator to get the value, right? So that's why the skill sort of like fades away. I've noticed students just don't know this understanding. So if you want, you can memorize this rule, write it down. It's a useful rule for when it actually comes about. For those who want to know where it comes or how it comes about, it's a very simple idea. It's just the idea of, say, if I got 3 to the power of 10, right? So it's base 3. What we're used to doing, actually I'll do to the power 2. We know the answer is 9. You see, what you might have learned from last year is that if this is exponential base 3, the inverse to that is log. So log is the inverse of exponential. But since this is base 3, it should be log base. What base? 3. Very good, Adonis. So log base 3, because those are inverses of one another. So if you did log base 3 of 3 squared, these are inverses, so they cancel out. And then whatever you do to the left, you do to the right. So it becomes log 3 of 9. So technically, 2 is equal to log 3 of 9, which is what you were familiar with. This is what they would have taught you last year to convert exponential to log. This is what log means. This means 3 to the power of what will give you 9. Yeah, so 3 to the power of 2 gives you 9. Makes sense. The problem, we can't do that. Well, back then we couldn't. We couldn't do log 3 of 9 if you had a scientific calculator. So let's dial back. What they did was they said, okay, so I can't do 3 square, I can't do log base 3. That's a problem. So what they did back in my days was they said, well, I only got log base 10 and log base e, so let's do log base 10. I do log base 10 on the left, then I do log base 10 on the right. These two can't cancel out. But I can use one of the rules that we have learnt so far, rule number 3 being the most efficient or most practical. So rule number 3 says you can drop down the 2, and then now you have 2 times log base 10 of 3 is equal to log base 10 of 9. But can you see where the rule's coming from now? See, I changed whatever base I wanted, and if I divide both sides, because that's times log 10 of base 3, base 10 of 3. So if I divide both sides, 2 equals 10 log 10 of 9 divided by log 10 of 3. But since both of them are equal to 2, see how they're both equal to 2? This is equal to 2, this is equal to 2. Well, that means log 3 of 9 is equivalent to log 10 of 9 divided by log 10 of 3. That's called the change of base rule. Okay, that's where the formula comes from. So that's why if you can't do log base a of x, you can change it to whatever base you want, and it just looks like the value divided by the base. Value divided by base. Okay? That concept will be useful for the very last question on that notes. Okay, so that you can have a try later. All right. There we go. That pretty much sums the notes of last year and a bit of depth of the change of base formula there. Let's flip over the page. I'm going to leave example 2 for you to try, but let's do a bit of solving. We'll do A and B, and then I can leave the rest for you to try yourself. Let's do A. Let's have a try A. Who wants to ever go with A? A should be the easiest one to start off with. Let's go with Una. I want to solve, what am I trying to solve? Solve for X. Oh, I think that's pretty straightforward. But anyways, yeah. X equals log 3 of 81. Yes, you're right. That's just saying 3 to the power of what will give you 81, and logically is 4. For those who don't know that, you could have done also an algebraic way. You could have done 81, so split it up into 3 to the power of 4. Use rule number 3, bring the 4 down, so it becomes 4 times log 3 of 3, and then Rule number 5. Get the same thing. Okay, but if you can read it, it's more efficient. Next one, let's try B. Who can I choose? Let's go Vibha. Let's try to solve for x now. I've got log base of x of 27 equals 3 over 2. What would you do first? Very good. This is log base x, so the opposite of log is exponential. So I need an exponential base x. So I do x, that's an exponential. To make it exponential, you've got to do the power of. So what I'm going to do is I say x to the power of log x 27. So I did x to the power of on the left. Now I do the same thing, x to the power of the right. Okay, so on the right I had 3 over 2, so I did x to the power of 3 and 2. On the left I had log base x of 27, I did x to the power of that. The nice thing is these are inverses. So they undo each other. That's the whole point. It's like times and divide and add and subtract. So I'm trying to remove that, and that now gives me 27 is equal to x to the power of 3 over 2, which is what Vibha was saying. And I'm still trying to get x. How do I get rid of that 3 over 2? I asked this last year, and I had like probably one student who knew that. Or maybe 2, but 1 spoke. The rest had no idea. What do you do here? Hands up if you have an idea. Leo. Yeah, that's it. It was just literally do the opposite of what you see there. Do the reciprocal. Because we know rule number 3 of index laws, if you have it to the power of something, power with a power, you times them. So if you want it to be x, x needs to be a power of 1. So 3 over 2 times what will make 1? 2/3. See rule number 3, you times these two. The 2's cancels out, the 3 cancels out, so you end up with 1. Whatever you do to one side, you do to the other. Raise it to the power of 2/3, both sides. 3 times 3 cancels out, 1 times 1 cancels out. So this is how you end up with x to the power of 1 is equal to 27 to the power of 2/3. And for some students who are weak with their algebra or index laws, they might stop here. Don't. You're meant to simplify it as far as you can go. 27, you can still break it down further into what, Luke? Very good. 3 cubed and then 2/3. And same thing again. 3 and 3. 3 2/3 cancel out. You get 3 squared. Yeah, the method works too. I was just showing the other way. And x equals 9. Okay, so taking it a bit further, if you left your answer here, the examiners will mark you down. They're probably looking for an answer of x equals 9 because it shows that you can work with your indices and break it down. Okay, so I just did the first 2 examples there where I'm applying index laws and logarithmic laws so that you can see how can we solve them. So one you can interpret, one you can actually go through the rules. This side there was a mixture of index and logarithmic rules. I'm leaving the other 3 for you to try. And the last one, there are answers on OneNote for you to look at. Okay, so have a look at the very last one. That one you need to use change of base rule. For most students in that exam, it wouldn't have taken them less than 30 seconds unless they already knew what to do, which most students would have taken a while to figure out. Okay. All right, I'm going to pretty much finish there. That's your session, and I'm just going to call up a couple of students to check their skills for Chapter 3. Because we are now well and truly in Chapter 5. So you've got to be at least on Chapter 4, very close to Chapter 5, not too far behind.